Hello again, we are finding the products of each of these questions here. We are finding the products of the matrices and we are using the formula row multiplied by column. Okay, so let's do number one. Okay, so in the first matrix, row 1, it only has one row and the entry is 4. The second matrix, if we look at column 1, it only has one number, which is 3. So the answer will be 4 times 3, and 4 threes are 12. Okay, this is the answer for number 1. For number 2, we look at row 1 of the first matrix and column 1 of the second matrix, and we multiply 6 times 5. Okay, so we have 6 times 5, and afterwards we multiply 1 by 7. Okay, 1 by 7. So we have plus 1 by 7. This results in 6 5s are 30 plus 1 7 is 7, and you get 37. So at this point in time, we notice that even though number 1 and number 2 matrices look too different because number 2 has larger matrices, somehow the answer for number 1 and number 2 ended up being the same size with only one number on the inside. So let's investigate this for a little while. So let's go back to number 1 and let's write the order of the matrix. The order of the matrix. So the first matrix has 4 in it. It has one row. It has one column. Okay. So the order of this matrix is 1 by 1. 1 multiplied by 1. Make this multiply a little clearer for you. Okay. The order of the second matrix, it has one row and one column. This is also a 1 by 1. And for the answer, one row, one column. This is also a 1 by 1. Okay, let's look at number 2. The first matrix has one row, two columns. So this is a 1 by 2 matrix. The second matrix has two rows in green and one column. So this is a 2 by 1 matrix. Final answer was 37, which is one row by one column. This is a 1 by 1 matrix. Okay, so we can see patterns developing here. Once these inner numbers are the same, for number 1 we had two ones on the inside, for number 2 we had two twos on the outside. We see that the matrices can be multiplied. Also, we find that if we look at the two n numbers, 1 1, there's a connection between that and the order of the answer. Okay. Okay, number 2, the two n numbers compare with the answer. So 1 by 1. Okay. Okay, so let us proceed now to do the third question. So we are multiplying row by column. Okay, so we will have 9 by 4. Okay, then we multiply row by the second column. We have 9 by 2. Multiply the second row by the first column, so we have 10 by 4. And we multiply the second row by the second column, 10 by 2. So we end up getting 9 fours are 36, 10 fours are 40, 9 twos are 18, 10 twos are 20. Okay, so let's analyze this question. We see that the first matrix had 2 rows and 1 column, so this is a 2 by 1 matrix. The second matrix had 1 row, 2 columns, so this is a 1 by 2 matrix. And our product, our answer, is 2 rows and 2 columns. So this is a 2 by 2 matrix. Observe again that once the numbers on the inside are the same, matrix can then be multiplied. So once the number of columns of the first matrix is equal to the number of rows of the second matrix, then the matrices are compatible for multiplication. We also see that the order of the product depends on the number of rows of the first matrix and the number of columns of the second matrix. Okay, so there's a connection between 2 by 2 and the number of rows of the first matrix and the number of columns of the second matrix. Okay, so I hope this was helpful to you, and good luck in your studies.